So I want you to think on which daily activities you use water. Probably washing your hands or brushing your teeth, going to the toilets, preparing your foods. Now I want you to think how those activities affect the quality of the water. Most of the time, it really doesn't affect it that much. You're just adding small quantities of things like detergent, maybe some dirt or some food residues. And that is called grey water. However, if you go to the toilets and you flush the toilet, you are producing black water. And that is because it contains fecal matter and urine that actually contains pathogenic bacteria, and also these liquids and solids are sometimes hard to treat. So from your perspective, this water simply disappears down the drain. But what happens? Well, it's transported via a complex network of drains and pipes that take it all the way from your home to a centralized wastewater treatment facility. And why do we do this? Because for many years we have recognized that simply discharging this wastewater into the environment causes pollution and also spreads disease. And what is the composition of this wastewater? Well, most of it's just water. But there's also a number of solids in there, sometimes solids that shouldn't even be there, like nappies and personal hygiene products. However, most of them can be either organic solids, like plant material, or inorganic solids, like sands and grits. And then you have dissolved solids, which are dissolved in the matrix of the water. And these can again be organic, like food residues, or inorganic, like salts. And then you also have nutrients, like phosphorus and nitrogen, that result from the intake of our food. And finally, you have small concentrations of pathogenic bacteria and also trace amounts of things like metals and maybe chemical products that result from our daily activities. And how do we treat this wastewater? Well, we rely on a number of different technologies that are based on principles of physics, chemistry, and biology. And I'll give you 3 examples. First of all, if we want to remove suspended solids in your wastewater, we can use something called sedimentation. And this means that these particles, by action of gravity and under certain conditions, will settle towards the bottom of the tank where they can be removed. The second technology would be flocculation and coagulation. And this is where we add a certain type of chemical, typically a salt of aluminium or iron, that will react with different components in your wastewater and form these bigger particles that then can also be separated by sedimentation. And finally, we can use something called activated sludge. And this is where we use natural bacteria that we have in our environment in a particular engineered system. What happens here is, just like you and me, these bacteria are able to use oxygen to breathe and to grow. And the food that they consume is your wastewater. And by growing, they will form these bigger flocks that then again can be removed by sedimentation. And what do engineers in this area do? They have to design these wastewater treatment plants, and they also have to choose the best combination of technologies for that particular purpose. They also have to do this using the least amount of resources and at the lowest costs. However, there are far more interesting challenges that lie ahead. What will these wastewater treatment plants look like in the future? As you probably know, we're moving towards a society that needs to be more sustainable. And we have to stop considering treating wastewater as a burden, but rather as an opportunity to recover valuable resources. And what resources am I talking about? Well, mostly it's water. And we can recover other things, like for example, carbon compounds or nutrients that are essential for our farming systems. We can recover bioenergy in the form of biogas that can make our wastewater treatment plants energy neutral or even energy producers. And we can recover more exotic things that are still being researched. Like for example, we can produce bioplastics from our wastewater, or we can mine precious metals from it. In summary, your used water has gone down the drain into a complex network of sewerage systems into a wastewater treatment plant, where it was treated and returned to the environment. However, with a new generation of engineers, we can think how we can treat this wastewater to be a pool of resources at the center of the circular economy.